Hello, folks. Welcome to Snowday. My name is Samartha Chandrasekhar, and I'm joined by Shruti Anand. We're both from Snowflake's product management team, and we'd like to go over what's new with cost optimization in Snowflake. For today's agenda, we have the following topics. We'll start off by going over an overview of Snowflake cost, including all of its constituent components. We'll then go over Snowflake's cost optimization framework and the three pillars around visibility, control, and optimization. And then we will close out by providing you with an overview, including lots of fun demos in terms of what's new, as well as best practices around these three pillars, namely visibility, control, and optimization. Getting started, here's an overview of the components of Snowflake cost. At a very high level, there are really three components. There is compute, there's storage, and then there is data transfer or networking. The compute component is typically what makes up most of a typical customer Snowflake bill. And in the compute component, our primary compute primitive called virtual warehouses is typically responsible for the vast majority of most of our customer spend. Virtual warehouses are essentially elastic, instant on, scale to zero compute artifacts that are essentially the place where most of your queries, jobs in SQL, Java, Python, etc. run. They also come with a per second billing model. There's another compute primitive that's called cloud services, which essentially represents the connective tissue, the Snowflake control plane, as well as sort of the compute footprint of running activities like query compilation, hosting, query result caches, etc. Snowflake provides a subsidy here up to 10% of your virtual warehouse spend. So if your cloud services footprint is below that threshold, which is the case for the vast majority of Snowflake accounts, you don't end up paying anything to Snowflake. Finally, there are serverless compute services such as query acceleration, materialized view, search optimization service, Snowpipe, replication, etc., where Snowflake manages the underlying compute in terms of right sizing it, in terms of ensuring it meets the needs of the load that these services are seeing, etc. And again, these serverless services incur a cost that's a function of the extent to which these services are used. There's also storage, which is typically a small fraction of the customer's bill. The important thing to note here is that Snowflake compresses the storage, and what you pay for is essentially the compressed storage volume and not the uncompressed volume. And that's another area where you can be beneficiaries of the work that Snowflake is doing behind the scenes, in this case, in terms of data compression. There's also data transfer, sometimes allude to this as egress fees or networking fees, etc. Is also typically a small fraction of the customer's bill. And this is something that you'll typically only see on your bill if you use capabilities like copy, which essentially is used for data ingestion into Snowflake, or for things like replication, where essentially you're trying to keep your Snowflake deployments in sync across multiple cloud regions or across multiple cloud providers. So that, at a high level, is an overview of Snowflake cost. Now I'm going to quickly transition over to Shruti, who will walk you through Snowflake's overhauled cost management UI.
Thank you so much, Samatha. That was some amazing insights, and I absolutely know that our customers are going to love it. Now, off to what are some of the new experiences that we are shipping as part of the new cost management interface on the Snow site. And I'll be taking you through the quick demo of what we have on Snow site as part of our PRPR coming in. So, as Samartha mentioned, we have a lot of exciting stuff that's coming around visibility, and one of them is the new cost management interface. Here, you can see a screenshot of the new cost management interface, which I'll be soon walking you through a quick demo as well. As you can see, this is located under the admin tab on the Snowsite UI, and you do need account admin privileges. And this is going out into PRPR. And we have some other stuff that I'll be walking you through the demo, which will be PRPR soon, which is very related to optimization. So without further ado, let's jump into the real-time demo. As I mentioned on the slide deck, the new cost management UI, you can now see it in a live environment. As you see on Snowside, I have account admin permissions and I am under the admin tab. If you're not a PRPR customer, you would see the old usage UI, which used to pop up under admin. But if you are part of our PRPR process, you see the new cost management interface. Now let's tie it into the three pillars that Samartha had mentioned. There are three pillars for cost that we are trying to focus on: visibility, control, and optimization. And that pretty much ties into our user experience journey as well that we see on Snowside. The first tab, which is the account overview tab, is very focused on two aspects: visibility And we'll also be talking about a feature called as cost insights, which is the optimization. So the next part is consumption, which is pretty much the usage UI that you had before if you're not part of the PRPR for the new cost management interface. And as Samarth had pointed out that, a major part of the cost journey is also the control aspects. And we'll be deep diving into these features, but we have budgets and resource monitor that lets you, do the control aspects around your cost management. Let's talk and focus about the visibility aspects. So if you are part of the PRPR, you'll be able to come to an account overview section. Now, what is this account overview page? The account overview page can be split into three core ideas. The first idea is as a cost steward or as an admin or anyone who wants to know around cost, you can come here and try to understand what does your spend look like overall. So for example, in this screen, you can see how much have you spent over the course of last 7 days. Obviously, you can change the time filter and go to the last day. You can expand it to last 3 months. But in this case, I'm looking at my spend for last 7 days, which looks like 6K, dollars. And you can also look at your spend based on credits. You can look at the price per credit. You can look at the average daily cost and the average daily credits that you have spent. It gives you a quick sense of, what are you trending towards. Now, the next part of the page is pretty much, the general fundamental concept that you need to know in order to understand what are your most cost consuming objects, right? So in this case, we have bunch of insights that can help you. For example, we have a tile which tells you what are your top warehouses by cost. We also have a tile which tells you what are your most expensive queries. We actually show you the query, we show you the total cost, we show you the cost per query, and the number of queries that are run. In the bottom section, we also have things around like, for example, you can quickly see this tile and see what are your top databases by storage. Now, let's say if I want to look at some most expensive queries, I can actually click on this list and I can see a much longer list of queries rather than seeing like, top 10 or top 12 queries if I want to further troubleshoot. The other cool thing about this UI is you can also look at the SQL that is generating this query and run it in your worksheet too. So that's about visibility. Now let's talk about the optimization. As part of Snowflake, we believe that we want our customers to have all the knobs in order to make sure that they are spending in the right way. And we are very excited to announce a feature called as Cost Insights, which is going to PRPR very soon. If you're registered as part of that PRPR process, which is going to happen very soon, you'll be able to see a new tile which is called as Cost Insights right on the account overview page. These are 5 insights which tells you, what are the opportunities to optimize your spend in a Snowflake environment. As you can see, they're surfaced right here. For example, I have an insight which is called as unused table with auto clustering enabled. And these are sorted by the most number of credits. So the one that is accruing the most number of credit will come on the top. Now, you as a user will want to understand, okay, what are these tables where auto clustering is enabled, and probably want to go and disable auto clustering on that. You can actually click on that particular insight and see more details. So in this case, you see a pop-up being open which shows you, how much credit was spent in last week around this insight, what are the tables that is being affected by this insight, and a breakdown by credit, the percentage of credit that it is accruing, and why this is important, and then certain recommendation in order to resolve that particular insight. In this case, you could take a simple actions like consider disabling automatic clustering on these tables. So all in all, as you can see, the new UI is very focused on the three pillars that we talked about. Account overview is a core foundation, targets on visibility, and then optimization, which is going to go PRPR soon. And then we have budgets and resource monitored, which focuses on the control aspects. Well, that's all that we had from the cost management interface perspective. Now passing it back to Samartha to walk you through the rest of the features.
Thank you, Shruti. Transitioning now from visibility to control, there are a few important best practices to be mindful of. The first one is around the best practices and guidance around auto suspend and auto resume. Now, as a quick reminder, Snowflake virtual warehouses have the capability to scale to zero, which means that when there is no work that's happening on the warehouse, that is, they're not running queries or jobs, a warehouse has the ability to go to sleep. And when a warehouse is suspended or sleeping, you're not paying for any money associated with that compute capacity. Now, there are a few nuances associated with this important capability, which really manifests itself as two features, which is auto suspend and auto resume. And these nuances are primarily around auto suspend timeout, which is the amount of time the warehouse will continue to stay running when there are no, after jobs cease to, be executed on that warehouse. Now, the important thing here to be mindful of is that each warehouse has an ephemeral cache, which gets invalidated when the warehouse is suspended. Now, based on the extent to which your workload can be a beneficiary of this caching, your auto suspend value can needs to be appropriately set. For example, if you have ETL or ELT use cases where the benefit of caching is kind of moot, where there's effectively, for all practical purposes, no benefit, we essentially recommend going and erring on the side of an immediate suspension if there is no new work on that warehouse. On the other hand, if your warehouse is driving BI dashboard or is running lots of select based queries and things like that, it is highly likely that it can be a beneficiary of caching. And in these cases, we recommend a higher auto suspend timeout value. By default, we've set it to 10 minutes, which we think will suffice the needs of most BI and select use cases. There's also probably sweet spots, in between either of these two extremities. And so for DevOps or data science use cases, it is entirely possible that other values might make sense. Usually 3 or 5 minutes is what we see make sense. So that is one important best practice that we recommend. And again, the key here to be mindful of is that a warehouse has the ability to scale to zero, but we've done a lot of work to ensure that uh, the main memory in each virtual machine that constitutes a warehouse cluster, as well as the local SSD on that virtual machine, can be used for caching both intermediate results as well as certain files that might be accessed from object storage like S3 on AWS. So this, getting this right is actually an important consideration. The other important consideration here is resource monitors, which is essentially a control construct that is scoped to the granularity of a single warehouse. And the important thing that resource monitors can do is that it can actually stipulate a hard limit, which is that if you stipulate a certain threshold, and if your warehouse reaches that threshold, uh, or reaches a certain sort of percentage of that sort of quota, you can stipulate behaviors like suspending the warehouse itself, or notifying yourself that a certain threshold has been breached, or you can perform both, suspend and notify. And again, this is a very powerful tool that exists that can help you sort of prevent runaway spend. The other caution here is that if you're using capabilities like sort of suspending a warehouse when a certain threshold is reached, it's a powerful feature. So we recommend caution while using that, because in some cases, suspending a warehouse can be tantamount to an outage if there are downstream workloads that are, or if the workloads running on it are servicing downstream customers that have some expectation of an SLO or SLA, etc. In addition, we have a new capability that was recently announced in public preview, which is called budgets. Unlike resource monitors, which are scoped to a single warehouse, budgets have a broader scope. So, starting out, budgets will be scoped to an entire account. So, this will have purview over an entire account spend, and a budget is essentially also a means to stipulate some sort of a spend limit on either an account or on a custom grouping of Snowflake's credit consuming resources. To illustrate this better, I'll quickly transition over to my browser window to show a working demo of this in action. So as you can see, this is the budgets UI under cost management. And as I mentioned before, there are two levels at which the budget or budgets can be used. One is on your Snowflake account itself. And then secondly, you can also apply custom budgets and custom groupings of credit consuming artifacts. Now, in this case, I have a budget that is set on a monthly cadence. By default, you can set a budget for each calendar month. Now, if I go look at this, I have a budget uh, that of 32,000 that I've set for the purposes of this demo. Now, to assist me in setting this budget, there are also numbers that sort of Snowflake shows me in terms of going over the credit footprint for the past 2 months, which can help inform the budget itself. And then I can go stick in my email address. I'll get notified if there is an overage. Now, speaking about the budgets UI itself, the important thing to note here is not only will there be a notification if the budget threshold, which represents sort of the spending limit for the month, is breached, but also there are proactive notifications based on the current trajectory of spend, based on the burn rate of spend that you're currently incurring. So, what you see here is exactly that. So, each day essentially adds cumulatively to the spend value, and there's a projection based on that. And then there's also this dotted line that represents the spending limit itself. So in this case, there hasn't been anything that has caused an overage. So for example, if I reduce this to perhaps 28,000, I should hopefully see that the spend limit line goes down. And in certain cases here, there is, or at least the current trajectory of spend sort of has me exceeding the budget value, in which case proactive notifications will be sent to the registered email addresses indicating as much. And that can inform downstream decisions such as negotiating with the powers to be to potentially increase the budget itself, or by highlighting the need for optimization activities to potentially do more with less. In addition, there are also custom budgets. So I have a number of custom budgets that I'd set up for test purposes. The workflow to set one up is pretty simple. So I go this button, I'll say demo snow day budget, probably set a 100 credit per month limit, and then I can go select a collection of credit consuming artifacts. So there are lots of warehouses in this account. Test is the one that I'm using, so I'm going to go associate that with this. And as you can see, I can attribute, or I can associate more than one credit consuming artifact with this budget itself. I can look at both sort of warehouses and other artifacts. For the time being, in V1, a budget is primarily tracking compute spend. We are looking to also, in the fullness of time, add support for storage and networking spend as well. So with those set of custom credit consuming artifacts, I'm going to go ahead and create this budget. Essentially, it'll provide a similar view for this budget itself. So this budget just got created. But for the purposes of this demo, I'd also pre-created a few budgets beforehand, along with which there were credit consuming artifacts that were linked to it. So, for example, under my budget, we had a number of warehouses. This one is going to be called the ServiceNow warehouse is consuming a lot of resources. So, in this case, the spend itself is greater than the budget threshold value. And in this case, the email address registered with this budget would be sent email notifications indicating that the current burn rate has the trajectory exceeding the budget value by the end of the month itself. All right. Now that we got done with control, with that demo of budgets, let's go over our optimization capabilities. At a high level, there are three types of optimization. There are transparent platform improvements that Snowflake performs behind the scenes that accrue value to customers. These are things that you can be beneficiaries of without actually opting in or doing any additional work. Secondly, there are serverless services that we provide to speed up workloads. And these include things like query acceleration, materialized views, automatic clustering, search optimization, etc. Now, the important thing to note here is these are also paid services. And we also provide, to a certain extent, value analysis capabilities that allows you to understand a priori the effect of using some of these services in terms of the cost benefit trade offs to your overall workload. And these represent, again, large opportunities, which in some cases can result in dramatic changes to price performance overall. And then thirdly, we provide what we call optimization data. And this can be used to help inform decisions around right sizing, ensuring that your utilization is up to mark, etc. Specific examples of these include warehouse load and warehouse utilization metrics. where we show you sort of the level of load on a specific warehouse for running jobs, for queued jobs, etc. And also, what's brand new is in private preview is warehouse utilization, where we show you the utilization of a warehouse as a percentage, not just at a per warehouse level, but also at the granularity of individual clusters if you're using a multi cluster warehouse. And using these two in conjunction, overlaid against a timeline, can actually help inform a lot of right sizing decisions for your warehouses. Secondly, we also have in private preview this thing that we call per query or per job cost attribution of warehouse spend. And this can help unlock showback or chargeback use cases where you can have a central team, for example, that's managing all of your compute, like a warehouse, which is shared across jobs or queries from multiple downstream business units. And then that central team might have to perform chargeback or showback to these downstream units. And having the per job cost um, or per job cost attribution of that warehouse's spend can really help in such use cases. It can also help with sort of stack ranking and sorting by the most expensive queries, so that you can choose those as candidates to optimize things. Furthermore, in addition to these warehouse and warehouse load level metrics and per job metrics, we also have individual sort of per query metrics as well, where you can get statistics on a per query level as well as on a per operator level. So you can, quickly identify things like, like Cartesian joins, or if you're performing full table scans, and the resource footprint of some of these operations, so that these get flagged as candidates to go optimize, that you can do so by writing your query differently. And these capabilities are available not just via the UI, but also via programmatic means. With regard to the transparent platform improvements and the benefits that it accrues to customers, we now have a way to quantify this mathematically, and we call this our Snowflake Performance Index, or SPI. And what we've shown is that from August of 2022 to April of 2023, there's been sort of a 15% reduction in terms of the amount of time that has taken nearly identical queries to run, which in many ways shows you this deflationary effect on Snowflake credits, which means the value of a Snowflake credit is going up by that much. Now we have an elaborate methodology in terms of how we compute the Snowflake Performance Index. First, we go look at stable workloads, that don't really churn, or whose churn is bounded by a certain percentile, and we go look at sort of the amount of time that some of these things take against normalized units of compute. And we have an elaborate blog that goes into the details of that. But the key takeaway here is that as a result of transparent platform improvements, it could be improvements like we're using a different VM SKU, or it could be improvements to our query compiler to reduce compile times, to reduce sort of the time associated with DML statements, to reduce the compile time for materialized views, and so on. We have been able to deliver to customers, with customers having to do no new work, or opting in explicitly, these benefits, which means, like I said, the value of a Snowflake credit is always going up. And like there's inflation in the real world, there's effectively a deflationary impact on Snowflake credits. Also, when it comes to optimization data that I was talking about, there are some high level guidelines and takeaways that we can provide, which essentially form a bunch of thumb rules around what you can do with metrics such as warehouse utilization metric, either at a per warehouse level or at a per cluster level, when combined with warehouse load metrics along a timeline, to inform decisions around right sizing your compute. At a high level, essentially, warehouse utilization gives you, it almost trivially provides guidance in terms of whether your warehouse is right sized or not. And then you can look at metrics like queuing metrics. So, for example, if your utilization is below 50%, you're not seeing queuing, and you're getting the kind of performance along the axis of latency or throughput that meets your needs, downsizing might actually be a viable option. Again, none of these are sort of set in stone, and all of these will require a certain amount of experimentation and trial and error. But what you see on your screen essentially represents a set of high level guidelines that we have provided in terms of how you can use this optimization data and these metrics to inform right sizing utilizations to maximize the value that you're getting for the compute capacity, aka warehouses, that you pay for. As closing thoughts, the call to action is to get involved. We have a private preview that's ongoing with the cost management interface. We encourage you to talk to your account team, get involved. Most of what we do is informed by customer feedback. So we're all ears to learn about your feedback in terms of what's working, what's not working, what else we could do for you. So I'll leave you with that thought. Thank you so much.